I think we could get started. Thank you everyone for joining today. We're going to be focusing on methodology breakdown for CDM AMS-III.AR. This methodology is focused on substituting fossil fuel-based lighting with LED CFL lighting systems. Before we begin going into methodology specifics, let's do a quick overview of who we are. Envision Blockchain Solutions offers expertise in the Web3 space, specifically in building and maintaining applications that help organizations navigate their Web3 journey, with our specialized focus on guiding organizations through the three major milestones of use case analysis, proof of concept development, and scaled deployments. We're uniquely positioned to help our clients achieve their Web3 goals. And with our expertise as the builders and maintainers of the Guardian, we offer insights and support to ensure that our clients stay ahead of the curve in this fast-moving and dynamic space. As you may know, the process of designing and collecting the supporting data for carbon claims is heavily manual and prone to errors. This can be due to a variety of factors, including poor data quality, a lack of assurance, potential double counting, greenwashing, and an overall lack of trust. The Guardian is here to address these issues head-on. By leveraging a cutting-edge policy workflow engine, the Guardian can mirror the standards and business requirements of regulatory bodies, creating extremely flexible digital methodologies known as DMRV. This approach not only helps organizations ensure compliance with regulatory requirements, but it also enables them to streamline their carbon accounting processes, improve data quality, and reduce the risk of errors and inaccuracy. So you could think of a policy inside of the Guardian as a digital version of a methodology. And by using the policy workflow blocks like Legos, you could design your desired workflow. Overall, the Guardian represents a major step forward in the area of carbon markets. It empowers organizations to take bold action on climate change with confidence and credibility, ensuring that they drive meaningful progress towards a more sustainable future. And to the right here, we have an image of our policy configurator where you could see our different blocks. And you can see that they're color-coded, so we have them based on UI components, server components, add-ons, and defaults. And if you're familiar with the Guardian, then you'll probably see some different tabs there that are usually not shown, and that's going to be our modules that we're going to be going over today. So at the heart of this ecosystem are four key technologies that enable us to deliver trusted and transparent solutions. First, we use decentralized identifiers. DIDs are globally unique identifiers that allow individuals and organizations to generate their own identifiers using systems they trust. By using DIDs, we can ensure that carbon credits are issued to the correct party and that they cannot be duplicated or manipulated in any way. Second, we use verifiable credentials. VCs are digital documents that provide information related to the subject, the issuing authority, and the type of credential, specific attributes of the subject, and evidence related to how the credential was derived. By using VCs, we can ensure that carbon credits are issued only to those who meet the necessary criteria, and that the credits themselves are valid and trustworthy. Third, we use verifiable presentations. VPs are a collection of one or more VCs. And finally, we use a public ledger technology and a policy workflow engine. Our policy workflow engine uses fully configurable and human-readable logic blocks that are accessible through either a user interface or an application programming interface, an API. This enables us to create highly customizable solutions that are tailored to meet the specific needs of each individual organization. By leveraging these technologies, we could deliver trusted, transparent, and customizable solutions. To the right, you can see an example of our trust chain, which is one of the key benefits of the Guardian, making it a crucial component of our fully auditable ecosystem. The trust chain allows us to track who did what from the very beginning of the workflow to the very end. This is essential for maintaining transparency and trust in the carbon market, as well as streamlining the verification process. By using the trust chain, we can create VC files that contain all the information that was input by different roles throughout the workflow. This information includes project details, issuance of tokens, and verification. This VC file is then stored on the Hedera public ledger, which allows for complete transparency and verification of the entire process. We have two versions available of the Guardian. There's the open source version that's available to fork and use immediately. You can find all the information for that on our GitHub. Then we have the Managed Guardian service, which is a comprehensive solution that provides users with resources, tools, and support. With two options to get started, users can choose between a simple user interface for developing policies and running proof of concepts quickly, or fully customizable APIs for a more tailored experience. In addition, MGS provides a scalable infrastructure that can handle heavy MRV data streaming requirements. Auto-scaling kicks in once consumption thresholds are met, ensuring that our solution can match the workload of our customers. This production-ready infrastructure is critical for ensuring our customers can achieve their goals with confidence and scalability. In today's webinar, we have a new methodology to break down with you, and this time it's focused on energy. We'll kick things off with a recap of our previous methodology breakdown webinars. And following this, we'll go over our policy creation checklist, which was created by our ESG consultants. This comprehensive guide aims to assist individuals and organizations who are interested in developing their own policies for implementation within the Guardian. Next, we'll introduce you to CDM's AMS-III.AR, a methodology for substituting fossil fuel-based lighting with LED CFL lighting systems, and provide you with valuable insights into their approach. And finally, we'll wrap up the webinar by demonstrating our Managed Guardian service and showcasing how it could be used to develop policies and mint tokens. We look forward to having you join us and learn more about these exciting developments. Let's start with the recap of our past webinars. Starting in February, we have been hosting monthly webinars as part of our methodology breakdown series. Each webinar focuses on a specific methodology from our open source library, and it's aimed at helping our users and anyone interested in the Guardian to understand how these methodologies can be streamlined for efficient implementation. Our first webinar was on Vera's DM17, which is a methodology for adoption of sustainable agricultural land management. The second webinar featured Vera's DM42, a methodology for improved agricultural land management, and we also compared it to DM17 using our policy differentiation tool. We also covered the comparison between Vera's methodology for afforestation, reforestation, and revegetation, and Gold Standard's afforestation and reforestation. This session explored similarities and differences between these methodologies, where we also used the policy differentiation tool. Another webinar was on CDM's AR-ACM-III, which is the methodology for afforestation and reforestation. So as you can see, we've had previous webinars focused on agriculture, land management, and afforestation and reforestation, but today we're going to be focusing on energy. You could also find all of our previous webinars on our YouTube channel. So moving into our policy development checklist, in this slide, we will discuss the essential steps you can take to create a policy for the Guardian. Creating a well-defined policy is crucial for effectively implementing the Guardian tool into your project. Let's go through these steps together. Step one is to identify the standard and an appropriate methodology. So you want to begin by identifying the relevant standard and a methodology that aligns with your project's goals and requirements. This will serve as the foundation for developing your policy. Step two will be to review the standard and methodology documents. So you'll want to make sure that you read through the documentation provided by the standard and methodology, ensuring that there's a comprehensive understanding of their guidelines, criteria, and principles. Step three is to identify roles, processes, and requirements. By identifying the various roles involved, you'll be able to define their responsibilities in the Guardian. Then you want to determine the necessary processes and requirements outlined by the standard. Step 4 is to identify input parameters and equations. So understand the specific input parameters and equations used in the methodology. These will be essential for accurately calculating and reporting the correct values. If you're using a policy in our open source library, then the equations will just need to be filled using our forms in order for them to be auto-calculated. Creating a new policy is different because the equations all have to be mapped out using a program like Excel spreadsheets, for example, and then the information will have to be implemented using our policy configurator. Step 5 is to create a workflow and schema. This is when you would develop a clear workflow and schema that outlines the step-by-step process for using the Guardian within your project. And this will help streamline operations and ensure consistent application. Step 6 is to finally build the policy for the Guardian. And if these tasks of developing a policy from the ground up appears unfeasible for you or your company, we do provide policy creation assistance as part of our Managed Guardian service. Now we're going into the specifics about the methodology we're going over today. So we know this policy is focused on projects that are substituting fossil fuel-based lighting with LED CFL lighting. But what we haven't talked about is why this is better for the environment. Fuel-based lighting is inefficient, provides limited and poor quality light, and exposes users to significant health and fire hazards. Over 95% of fatal fire-related burns occur in low and middle-income countries. So adding this to this problem, fuel-based lighting also produces greenhouse gases, which leads to increased indoor air pollution and associated health risks. It inhibits productivity and jeopardizes human safety. The total consumption of fuel for lighting is equivalent to 1.3 million barrels of oil per day and results in carbon dioxide emissions of about 190 million tons per year. LED CFL bulbs outshine fossil fuel-based lighting for several reasons. They're highly energy efficient, using up to 80% less energy compared to traditional bulbs. This translates to significant energy savings and reduced carbon emissions. LED CFL bulbs have an impressively long lifespan, lasting up to 25 times longer than conventional bulbs. This means fewer replacements, less waste, and lower maintenance costs. Lastly, LED bulbs are environmentally friendly, as they do not contain harmful substances like mercury and produce minimal heat, making them safer and more sustainable choices. CFL bulbs do contain small amounts of mercury that can be released into the environment if they break. However, switching to compact fluorescent light bulbs saves energy, which reduces dependency on fossil fuels that are burned to generate electricity. Since LED CFL bulbs are more efficient, they have a longer lifespan, which also reduces the use of resources in production. So a quick overview of CDM's methodology. CDM's AMS-III.AR methodology is associated with renewable energy and energy efficiency. The typical projects include activities that replace portable fossil fuel-based lamps with battery-charged LED or CFL-based lighting systems in residential or non-residential areas. This methodology references several tools, which include Tool 7. This is a tool used to calculate the emission factor for an electricity system. And it also references Tool 33, which includes default values for and parameters. Along with digitizing the methodology itself, we have also digitized Tool 33 and used it as a module within our policy. This allows us to use those default values in our calculations. And not only can it be used for AMS-III.AR, but it can also be used as a module in any other methodology that references Tool 33. The last item referenced in this methodology is used for sampling and surveys. So we could take a look at the annual emission reductions. This equation is used to calculate the annual emission reductions, and it's also what we'll be minting against today in our demo. In green, we have the emission reductions, and that's what we're looking for. In dark blue, we have the number of project lamps distributed to end users. In light blue, we have the baseline emissions per project lamp. Then in light orange, we have an average project emission per project lamp. Then in dark orange, we have the percentage of project lamps distributed and that are in operation. So keep in mind that all of these are in respect to the year that you will be calculating for. The product of N here is the difference between the baseline emissions and the project emissions, and then that's multiplied by that last one, which was the percentage of project lamps distributed. And then you'll have all of those resulting values summed to calculate the emission reductions of that year. So before we move into our workflow, we're going to take a look at our schemas in the Excel spreadsheet. And this is how we organize everything before all the information is transferred into Guardian. At the top, we have our different schema types. So we have our required fields, schema types here with our strings, address, phone number. We also have our questions tab, allow multiple answers, and the answer. This is going to help us know how to input it into the Guardian. And then each one of these gray breaks here is going to be our schema. So we have our project detail schema. It's going to take pretty general information about the person or organization that's doing this project, where it's located, what methodology they're using, monitoring plan, etc. Then we move into the minimal requirements for the design specifications of project lamps. None of this is going to be used in the calculations. However, it does need to be filled out, which is mentioned within the methodology. Then we move into our default values. And as you can see, there's a lot of green going on here. This is because it's all auto-calculated. So when we move into our forms, if you've seen our previous webinars, it's going to be very simple compared to the ones we've done in the past. A lot of this is auto-calculated, like our default values. Everything within this schema is actually Tool 33 that we'll be using as a module. Tool 33 also has a table where we'll be able to select our load factor of either 25%, 50%, 100%, and the size. And depending on what you select here, it'll be your emission factor that's going to be auto-calculated using that tool. If we scroll down, we have our baseline emissions. For this specific methodology, the baseline has a default value. So you're not going to have to fill out anything for the baseline emissions as it's being auto-calculated. Now we have our project emissions. All you'll have to fill out there is these 4 variables. Everything else will be auto-calculated. And we have our emission reductions. This is what we're minting against. We're going to take a look at the workflow and what a module is. So here we have CDM's workflow. We have in blue our project proponent. In orange is UNFCCC, which will be our registry here. Green is the BVB, and that yellow gold color is the designated national authority. Starting at the top, we're going to have the project proponent prepares and documents the project description, and that'll be submitted to CDM. Then we have the designated national authority will approve the project description. Our registry will add the project to the project pipeline, which is UNFCCC. The designated operational entity, which we will refer to as the BVB in this case, will assess and validate the project description and provide a validation report. Then UNFCCC will add the project to the project registry. The project proponent will then conduct their monitoring and send the monitoring report to the VBB. And the VBB will assess and validate the monitoring report and certify the project. Then the final step is UNFCCC will review and issue the CER. So before we start our demo, let's take a look at what a module is. Modules are like building blocks that contain specific functions and features. They're designed to make it easier to develop policies, workflows, and other system functionalities. By using modules, you can reuse and enhance existing components, making the system more flexible and adaptable to your needs. Having modules will allow you to reuse certain parts of a methodology. In this case, we could reuse Tool 33, which provides us with default values in projects that are focused on energy. Keep in mind, though, that you would only use that module if the methodology references it. This not only happens in energy-based methodologies, but it also occurs in a methodology like afforestation and reforestation, where we see tools or smaller methodologies referenced in order to calculate, for example, the carbon stock in dead wood or litter. So here we have an image of what a module would look like in the policy configurator, but we'll take a deeper look at that in just a second when we move into our demo. All right, so here we are on our Managed Guardian service. We can take a look at the top where we have our user profile, our tokens tab. We also have our policies tab, but we can select here on modules and we'll take a look at Tool 33. This has been imported. You'll also see it reflect when we click on our policy and we select this edit button. So here we have all of those technical workflow blocks. You can see we have our different colors for the UI components, server components, add-ons, defaults, and you could see all of that organized here to the left. We have these two additional tabs, which is our module. This is for the project information, and then we have it for the report information. If we select this button right here, or block, you could also see the properties, but if we click on the JSON, we can go down and see it's probably a bit difficult to understand, but this is all the information that was within our Excel and in that table. And it's going to list out where all that information has to go into the other blocks as well. We also see that the type of block that all that information in was in our custom logic block. And if we go into the policy and we scroll down, you're going to see those modules in here again. And now when we fill out all of our forms, all of that's going to be used to calculate our final emission reductions. The very end where we have our mint token block, our minting events. Could also take a look at the schemas. Here we have the different ones. Those were those different tabs within our Excel. And let's start our policy demo. So we're going to switch this from draft into dry run. And we could select go. As we mentioned within our workflow, we have different users here. Right now, we're currently just the administrator, which is going to be our standard registry. And we're going to create these extra users. So we have our project proponent, our VBB, and the designated national authority. And by clicking on user one, we can assign a role. So we're going to assign project proponent to user one. Then we can move down to user 2 as the VBB. And we're going to name the VBB for this demo. It'll just be VBB. And you see it says waiting for approval. We'll get back to that once we assign our last role to user 3, which will be the designated national authority. And we'll select OK. So now we know the VBB said waiting for approval. We're going to go back to the standard registry, our administrator, where they could approve that VBB. So we see we have an approve and reject button. The standard registry could take a look at all of the information that the VBB had to submit and select approve. You also see that the standard registry has different tabs up here. We have our approved VBB, project pipeline, monitoring reports, token history, trust chain, and we'll be moving through these as we go through our demo. So now we're going to go back to the project proponent and select new project. This is how we would create this. And this is going to be all the information that was in that Excel, and we're going to be filling this out. For this demo, I'm going to be using X's as any text. And our values are also default or demo values. They're not associated to any specific project. So we're seeing all that information from our project detail schema. We're going to choose the crediting period. And we'll scroll down and we have our monitoring period. And our monitoring plan. Then we'll be moving into the schema that was for minimal requirements for the design specifications of project lamp. None of these values are used in auto calculations. It's just information that you could probably get on the nameplate of that lamp. And now we're going to select our load factor. This was that table I showed in the schemas that will give us the emission factor. Now our project emissions, the reason why we don't have to fill out our baseline emissions was because it's all auto-calculated for this specific methodology. The type of project lamp, the type of charging mechanism, the wattage of the lamp, and the charging capacity. And then finally, we have to fill out the number of project lamps. We'll say 1,000 for this example, and the percentage. We're going to put 1, which should be 100%, and select OK. Now we see it says waiting for approval. In this specific workflow, the designated national authority will be approving this. They can view that document and see what that project is, the information for the project. And we're going to select validate. Then we'll be going to our administrator, which is the standard registry. And they'll be adding that to the project pipeline. They can also click view documents and see all the same information that was filled out. And we're going to select add. Now it says waiting for validation, but before the VBB receives this information, the project proponent has to assign the VBB. Here we have a drop down, and we could select the VBB. And now the VBB has access to this information, where they could also see this document with all the project information. Sorry, it's in the projects tab. They could review that and select validate or reject. We're going to select validate for this demo. And now we're going back to the administrator where this project has to be added to the registry. Going back to the project proponent. Now they could fill out their report. So based on how often they have to update the information, they can do that here. And at the very end, you could also add a picture of where this project is located. Select OK. And now we could go back to the standard registry for our final step here. Going to the monitoring reports tab. And before we do that, we're going to go to the VDB and select on monitoring reports. And they also have to verify that monitoring report. So they could see any information that's been updated, as well as the map. And then they're going to select verify. And now we could go back to that final step. So now we see we have a mint button here under our monitoring report. And we're going to select mint. It went from minting. In just a second, it'll say minted. And then we could click on token history. You'll see how many tokens were minted for that project. We have an amount of 8. And going to our trust chain, we have our VP that we spoke about in the beginning of this webinar, and it's going to have our trust chain at the very bottom with all the VC files. So you could see the token, the recipient name, token amount, mint date, verified signature. You have policy information like the policy name, the description, are we in dry run, and the issuer's name. And now you see we have from the very beginning of the account was created, you could see a VC file for that and all the information associated with it. And as you go down, we keep seeing the different steps that we took. We created the project. We have the automatic completion of our default values. If we take a look here, we have all the information that we filled out, as well as all the default values that were done with the auto calculations. We have the automatic completion of project fields, approving the project. Every single step that we've done is going to reflect here. You could also see the VC file for it. You could see who did it, making it easier to audit this project. All right, well, thank you all for joining, and I do hope to see you in our webinar next month. It'll be the 6th one out of our series. Thank you for joining.